Okay, so this problem says some incandescent light bulbs are filled with argon gas. What is the VRMS? V root mean square speed. You can think of roughly as the average speed. Okay, for argon atoms near the filament, assuming the temperature is 2,500 degree Kelvin. Okay, so again, so for these bulbs, you can assume the incandescent bulbs, the filament temperature is that, and what is the speed of the air molecules, average speed of air molecules inside that bulb. Okay, so you can roughly think of, and you can look up your notes. VRMS is given by 3 times square root of 3 times RT divided by the molar mass. It can be, so you can write it like this as well, 3 times KT divided by the mass of individual atoms. Okay, argon is a monoatomic gas. So this is the mass of a single atom, and that's Boltzmann's constant, or this is the mass of 1 mole of argon gas, and that's the gas constant. Okay, so you can use either formula. Of course, we'll use this one. All right, so VRMS, I'll write it again, 3 RT divided by N. And M for argon, argon is AR is, if you look up the tables, that's 40 grams. So 1 mole of argon gas weighs 40 grams. Everybody see that? It's that red number. This red number, 40 grams. Okay. All right, so VRMS is equal to 3 times 8.314 joules per mole per Kelvin. The temperature is 2,500 degree Kelvin. And 40 grams, we have to convert that to kilograms to the power 1/3, or 1/2. Okay. So, okay, so what I'll do is, again, here's a good habit to get into, take care of powers of 10. If it simplifies, we'll say this is 2.5 times 10 to the 3. Huh? Where's the icon for the Wi-Fi connection?
Why is it screened like this? You're plugged in, isn't it? That's
I think if you've been in my Chrome,
Hmm?
for some reason it's on the Chrome bar and not your actual taskbar. There it is.
It is there. Right. Hang on a second. So let's just hang on a second.
yeah, that's your own air.
I'm going to assume it's still recording all of that because I'm not going to do this again. Okay, again, here's what you want to take care of. Powers of 10. This is 10 to the power 3. It'll come to the top. We'll make that 2.5 times 10 to the 3. Half of that is, so that's 10 to the 6, and half of that is 10 to the 3. So here's what this is essentially what I've said. So this is 3 times 8.314 into 2.5 divided by 40 to the power half, 10 to the 3, and this is the speed, so it'll work out in meters per second. Okay. Okay, so this works out to 1.25 times 10 to the 3 meters per second. Okay, so that's a kilometer. Oops. So 1.3 kilometers a second. So essentially, roughly a mile a second. Okay. Eighth of a mile a second. All right, do you guys have any questions before we stop this recording? Okay, hang on a second.